this is Enzo from Group 2, and I wanted to let you guys know my thoughts on the project when we were, supposed to do it, the whole Sessa's wheat thing and the Gampels. I thought,
this is blasphemy! This is madness!
But then I realized,
this is
Sessa! So yeah, I hope you enjoyed the project.
This is Morgan Tarleton for Team 2.
Elizabeth.
This is Sean Patrick Bushy.
And Enzo Marino. In order to solve the problem we were all charged with, our group followed the following steps. First, we found the number of wheat grains, Sessa 1. That in itself was fairly self-explanatory. Second, the volume of Gampel was searched for on the internet, and two very helpful bits of information were found. One was the number of golf balls that would fill the pavilion itself, and the other was the density of a grain of wheat. Third, the volume of a single grain of wheat was found through some conversions, and with the help of the discovery that a grain is a unit of mass for the average weight of a single grain of cereal, the volume is thus found. Fourth, the average volume of a golf ball was found. Fifth, the true volume of Gampel was found. That'll be explained later. Sixth, the number of wheat grains that could fit into a golf ball was found, and the number of wheat grains that would fit, the number of golf balls that would fit Gampel was also found. So we had the number of grains of wheat that roughly fit in Gampel. Seventh, the volume of the entire building was found. This would include bathrooms and closets and things. Eighth, a percentage of wheat was added to the number to compensate for the empty space between golf balls. Ninth, the volume of Gampel was added to the volume of the entire building, and this was all added to the wheat that would compensate for the empty space made by the golf balls. Eighth, the problem was solved, the answer was found. Note that the volume of the entire building is percentage of the Gampel dome area itself. To figure out how much wheat the king owed Sessa, we started with one grain and began doubling it for each square. After a while we noticed a pattern. For each square, the amount of grain owed was 2 to the power of something. For the first square, Sessa owed 1 grain of wheat, which is 2 to the power of 0. For the second square, we doubled 1 to get 2, which is also 2 to the power of 1. For the third square, we doubled 2 to get 4, which is also 2 to the power of 2. Therefore, to find out how much wheat was owed, we just continued the pattern until the 64th square. Once we figured everything out, we added the number of wheat per square together to get a total number of wheat which was owed to him, and this came out to be this number of grains of wheat.
Step 2. From here we decided to look up the volume of a grain of wheat and found that it was approximately 0.0820 cubic centimeters.
To find the volume of a single grain of wheat, what was done was looked on the internet for the volume of wheat, and what was found was a density to volume conversion. So in the conversion I plugged in 1 gram of grain wheat and figured out that it would be this much volume. And then using the density volume mass formula and knowing the mass of a single grain, which is the average mass of a single piece of cereal, I was then able to find the volume in centimeters cubed, and that's what we've been using for the rest of the problem.
Step 3. We found a website that told us the number of golf balls that would fill the diameter of Gampel. The website said that based on the dimensions of Gampel, this number of golf balls would fit inside of Gampel.
Step 4. We realized that this website didn't take into consideration that much of Gampel is taken up by structures such as walls, bleachers, etc. We decided to estimate that 55% of Gampel is taken up by these structures. Therefore, to get the true amount of golf balls that would fit in Gampel, we took 45% of the number of golf balls to conclude that Gampel actually holds this number of golf balls.
Step 5. Then we had to figure out how much wheat this was equal to. We found out an average golf ball had a volume of 40.7 cubic centimeters. Therefore, we divided 40.7 by 0.0820, the volume of wheat found in step 2, to conclude that there are 496.34 grains of wheat per golf ball.
Step 6. From here we had to find out how much wheat would fit into 1 Gampel. To do this, we multiplied 496.34, the number of grains of wheat per ball, by 42,779,571.3, the amount of golf balls Gampel holds as seen in step 4, to get this rather large number, which we concluded was the amount of wheat held in 1 Gampel Pavilion.
Step 7. We were going to stop at step 6, but we realized that there was much more to Gampel than the open space. We had to consider that all doors were open, and therefore the bathrooms, closets, and hallways also needed to be included. To do this, we assumed that there was about 30% more space in Gampel that we needed to consider. Therefore, we needed to take 30% of the wheat per Gampel concluded in step 6 and add it to that number. 30% of this number came out to be that number, and once added to this number came out to be that number.
Step 8. We also realized that when you pile golf balls together, there is a lot of empty space in between the balls. We realized that extra grain could fit into this space. We assumed that there was about room for 15% more wheat to fit in between the golf balls. 15% of this number is this number. We added this number to get a total of this number. Therefore, our final conclusion was that one Gampel Pavilion could hold this amount of wheat.
From there, we needed to find how many Gampels we needed to hold all of the wheat that Sessa was owed. To do this, we divided the amount of wheat owed to Sessa, this large number, by the amount of wheat we concluded one Gampel could hold, this number, to get this third number. Therefore, we concluded that we would need that many Gampels to hold all of Sessa's wheat.
Now, I don't think anyone expected a number that big for the answer. This was a really cute problem with an extremely sexy conclusion. And I, for one, am glad I took this class and was able to do such a fun problem. This, ladies and gentlemen, was Sessa's wheat.
They seem to be gorged.
Gorged? On my grain? Kirk, I am going to hold you responsible. There must be thousands of them.
Hundreds of thousands. 1,771,561. That's assuming one tribble, multiplying with an average litter of 10, producing a new generation every 12 hours over a period of 3 days.
And that's assuming that they got here 3 days ago.
And allowing for the amount of grain consumed and the volume of the storage compartment.